Now, typically when you have exponents on both the sides, what you just do is take the log to the same base and it will cancel out. But unfortunately, you'll see over here that you have base 2 on one side and base 5 on the other side. So what we're going to do is, to fix this problem, we're going to take some kind of common base, and the most standard common base to take is either ln, which is the natural log, or another option is to just take log, which is log base 10. So I'm going to take natural log on both sides of this equation, and so I get natural log of 2 to the 3x minus 1 equals natural log of 5 to the 2x plus 4. Now remember, according to log rules, whenever you have natural log of b to some power a, by the power rule you can bring this a in front of the natural log and you get a natural log of b. So I'm going to apply this formula and I get 3x minus 1, the entire power comes down, times natural log of 2 equals 2x plus 4, the entire power comes forward, the natural log of 5. So just to be clear, in this case, in both of these cases, the 2 is the base, and here like the 5 is the base. Whereas on the other hand, the power that you have up here is like the a. So that's how that works. Now I'm going to first of all, let's take into account the natural log of 2 and natural log of 5 are just numbers, they're constants. So we're going to multiply these things out since we need to solve for x. So in order to do that, I'm going to use distributing both the terms inside the parentheses. I'm going to do it for both of these terms. Should have had the arrows the other way around. Okay, so I have 3x times natural log of 2 minus, well, 1 times natural log of 2 is just natural log of 2, equals, I multiply the natural log of 5 inside, so I have 2x times the natural log of 5 plus 4 times the natural log of 5. Now I know you have a lot of alphabets and numbers here, so this might look confusing, but I'm going to outline what the constants are and what the variables are. So wherever you have x, so these are the terms that have x, those are the only variable expressions. Everything else is a constant. So what I'm going to do is I'm going to take the constant terms over to the same side, and I'm going to bring the non-constant term over to this side. Now in order to do that, I'm going to do exactly what I do to solve a linear equation. To take negative natural log of 2 to the other side, I'm going to add natural log of 2 to both sides of the equation. And in order to take 2x times natural log of 5 over to this side, I'm going to subtract 2x times natural log of 5 from both sides of the equation. Now once I do this, so from the left hand side natural log of 2 cancels, and from the right hand side 2x times natural log of 5 cancels. So I'm left with 3x times natural log of 2, and now remember I brought the negative 2x natural log of 5 over here, equals, I had 4 times natural log of 5 on this side, and plus I added natural log of 2. Again, what we're looking to do is solve for x. So I have an x on both the terms on the left hand side, so I'm going to factor it out, factor out the x, and I'm left in the first term with 3 times natural log of 2, which is a constant, minus 2 times natural log of 5, which is again a constant, equals the same thing on the other side, 4 natural log of 5 plus natural log of 2. And the final step to solve for x is to divide by whatever is multiplied by x. So this entire thing over 3 times natural log of 2 minus 2 times natural log of 5. Divide both the sides by the same thing. And so from the left hand side you can cancel this entire expression, And you're left with the final answer, which is x equals 4 natural log of 5 plus natural log of 2 over 3 times natural log of 2 minus 2 times natural log of 5. I know that looks really complicated, but all of these terms, remember, are constant, so you have your final value of x.